So now we want to find the balance of the account at the end of the 60th month, correct to the nearest dollar. So for here, I might actually just share a new screen because I will get a nice clean screen. So that was, we ended up with our second month being 500 bracket 1.003 plus 500 outside of 1.01 outside of 1.003, right?
Yeah.
So for our third, we're going to, and don't worry, I'm not going to do this 60 times. I just want to show you the pattern here. So here, if this is at the beginning of my third, so third beginning, I get 1.003 squared plus 500 1.01 1.003. Now, what am I going to do here? I'm going to add 1% of my last deposit, right?
Yeah.
What was my last deposit, though?
500 times 1.01.
Yeah, exactly. So I'm going to have to take 500 and then 1.01, and then I'm going to have to multiply that by 1.01, right? So what does this become? This becomes 500 bracket 1 plus 003 squared plus 500 1.01 bracket 1.003 plus 500 1.01 squared, right?
Yes.
So we're starting to see a pattern here. And then if we add the interest, it will really start to see a pattern. Because if we multiply all of these by 1.003, what do we get? We get 500, and that's going to raise this one to a new power, right? And then plus 500 1.01, and then that's going to raise this one to a new power as well. So 2 plus 500 1.01 squared, and that's going to be bracket 1.003, right?
Yeah.
So this is going to continue on each time. So notice how we're adding on a new term, and this term is increasing by 1.01 squared, right?
Yeah.
So it was increasing by 1.01 each time. So for, let's say, T60, actually, I'll use A and you'll see why. So A60, because that's going to be my amount in the 60th month. So this is my third month, and I've got a power of 3 here. So what that means is I'm going to get 500 1.003 to the power of 60, right?
Yeah.
Plus, and then I'm going to get my 500. And notice how that's going to stay 1, but this interest is n minus 1 for my nth term, right? So if this is my third term here, then that's going to be 2. And for my second term, that's 1. And if it was my first term, that'd be 0, right?
Yeah.
So that means that's going to be 1.003, and that's going to be to the power of 59. Does that make sense?
Yeah.
And then I'm going to go plus. That just means I don't write all the terms in between. And then my last term is going to be 500 bracket 1.01 to the power of 59 bracket 1.003.
Yeah.
So does that make sense?
Yes. Yeah, I see that.
All right. So everything there is okay. So this is a general expression for our annuity, but Do you want to put that into your calculator? Like all of those 61 terms?
No.
No, not really, do you? So we're actually
because
going
that's
to
gonna
try and,
take a while.
yeah, so we're actually going to try and split this up into a sequence then, and that's going to let us essentially just have a better time with it.
Mm.
So now we're going to pull out a common factor so we can just simplify this down to a nice sequence, right?
Yep.
Now that sequence that I'm going to pull out is actually going to be, oh, I did the bracket wrong. Yeah. So this is, another way of writing this is 500 outside of 1.003 to the power of 60, right?
Mm-hmm.
So then what do we get for our first term?
1.
Yeah, 1. What do we get for our second term?
-1.
Well, we're going to get 1.01
over 1.003.
over 1.003. And then what about for our second one?
1.1 squared over 1.003 squared.
Yeah. And then we can pull out, so so we can keep going until we get to 1.001, and this goes up to 59.
Yep.
So the maximum is going to be 59. And then if we divide
Over
that by 1.003 to the power of 60, we're going to get 1.003, 59. Perfect.
Mm-hmm.
So then from here, let me write this a different way, and you'll pretty easily be able to see the parallels with the geometric sequence. So 1 plus 1.01 all over 1.003 plus 1.01 all over 1.003 squared.
Yep.
So I'm just bringing that common power out to the top to the power of 59, right?
Mm-hmm.
So what's this?
It's geometric.
Yep. And what's my A?
1.
Yep. And what's my
Or do
R?
we still use, okay, 1.101 over 1.003.
So what were you saying?
And I was just saying, because I thought A would be our first value, which was 500, but it would be 1, wouldn't it?
No, because we're using this
in
new
the actual,
sequence. We're
yeah.
disregarding that left bit for now.
Yeah.
So this is just a nice long sequence. Can you sum a geometric sequence?
You can find a limiting sum.
So
Oh, actually, yes, you can,
yeah,
because we have a final value.
yeah, we have a finite number of terms.
Mm-hmm.
So in that case, what are we going to have?
We use the like geometric sum.
Yep.
Equation. I think that was like A times R minus 1 over R minus 1. And it was something like that.
So A times R minus 1.
Probably not that, but it was
No.
something.
Sorry, I just don't remember it off the top of my head. I need the formula.
I think it's no.
Oh, yes, that's it.
Oh yeah, is it R to the n minus 1?
Yeah, so it's, have you gotten all of this down?
Almost.
I'm
just on the last line.
Oh, yeah. So I'll just write it up here in red, so that way it's distinct. So then Sn equals to A1 or A bracket 1 minus R to the power of N all over 1 minus R. That's not quite correct for this one. That's going to have to be the other one. That's going to have to be the other one, which is the other way around. Sorry. So we actually have two
Okay.
equations that we use. And
Is
so
this
this
r
is,
to the n minus 1?
yeah, so this is if r is less than 1, and this next one's if it's greater than, which in this case it is because it's 1.01 over a smaller number.
Yeah.
So it's going to be a rn minus 1 all over r minus 1. So this is for r greater than 1. Does that make sense?
Yeah.
And then you can just substitute that in, and then you'll get a nice, I mean, it's not going to be great because you're going to have 1.01 to the power of 60 over 1.003 to the power of 60, and that's going to be minus 1 over, yeah. It's not going to be the nicest fraction, but if you combine it, it's pretty something you can put into your calculator pretty easily, right?
Yeah.
So have you finished?
I'm just writing down the equation and solving it.
All right. So in that case, I might just rub out this top section if you've written all of that. And again, like Sung said, this will be recorded, so you'll be able to access these as well.
Okay.
So I'll just take all of that out. There we go. And draw that. So now we're going to use SN. So actually, let me write this out properly. So this is going to be A60 equals to 500 bracket 1.003 to the power of 60 bracket, and then we're going to have we're going to use this formula over here. So we're going to have 1 bracket 1.01 all over 1.003 to the power of 60 minus 1 all over 1.01 over 1.003 minus 1. And then from there, you can put that into your calculator and you'll actually get a solution.
Okay.
And what, yeah. And your solution should be
44,404.4.
Yeah, exactly. That's a
lot of fours.
Yeah, it is a very interesting value.
Mm.
44,000
404.
404.4. And
Yep.
what's this?
What is? Oh,
It's
is
be
it
dollars,
dollars?
right? Yeah.
Yeah.
Because this is the amount you've got.
Yeah.
So if for, let's say, 60 months, if you were to put 500 at plus 1% of 500 in each time at a 0.03% interest rate, you would have this after 60 months, so 5 years.
Hmm.
That being said, your deposits at the end are going to be very large.
Yeah.
Because you'll be depositing 500 times 1.01 to the power of 60. So that's a very large deposit.
It is $980.
Yeah.
About.
So it's a lot larger. Well, it's not a lot larger, but it is definitely larger than your initial deposit.
Mm.
But yeah, no. So after 5 years, you could have $44,000 in your account. So
well,
the
I think
financial,
if you have a good enough salary, that would probably be not that big of a deal.
yeah, it'd be pretty reasonable because that would be less than $12,000 a year.
Mm.
Yeah. So, and that's one of the reasons why we use these formulas, because if you're, the financial maths of this course is probably one of the more applicable to your, whatever you're going to be doing, because like the coordinate geometry, the statistics, particularly the statistics stuff, it's useful and it's really necessary depending on what field you're going into. But the financial stuff sort of applies to everyone because everyone's going to be getting loans, everyone's going to be having a bank account or a credit card or a mortgage. And so
Yeah, true.
pretty much no matter what, this stuff will be important.
Yeah.
Yeah. And it's actually really important with like home loans in particular, because people will say like, you know, this interest rate with this compounding period and things like that, it's really important to be able to calculate and actually compare the two, rather than just going, oh, this one's got the lowest rate, but actually they're doing the compounding daily, so I'm actually getting charged a lot more than if it was a higher rate charged monthly.